In this short mini video, we are going to look at two examples where we are calculating the work that's being done, meaning the application of force being applied through a certain distance using vectors. So there's a few things that we need to keep in mind. First, our formula is going to be that work is equal to force dot product to your distance. Okay, so here is our formula that we care deeply about, where D represents the vector of motion and F is going to be your vector of force applied, or your force applied. So in this first example, it says find the work done on a particular move on a particle moving from J to K if the magnitude and direction of the force are given by vector V. So here we're told that J is at the point, the coordinate point, 3, -3. K is at the coordinate point 5, 1. The vector that we have is going to be 6i minus 3j. And so we have to figure out what it is we need to do. Well, the first thing that we need to do is we need to recognize we are talking about a vector. So we're starting and moving from J to K. And we know that J was going to be at the point 3, -3. And we know K was going to be at the point 5, 1. Okay, so that's what we have. And so we need to be able to calculate our motion. So first and foremost, let's go ahead and look at D, or the vector of motion. And we have to be able to calculate its components based on the coordinates. So remember, to calculate components says you're going to take your ending value minus your starting value. So this is going to be 5 minus 3, and then it's going to be 1 minus a -3. So my motion vector is going to be at the point 2, 4. And now we need to look at what is my force vector. Well, my force vector is represented by V. Why? Because it says direction of the force given by V. So here this is going to be 6i minus 3j, which is going to be the component 6, -3. So now all we have to do is find our work. So again, work is going to be the force dot product with your motion vector or distance. So here my work is going to be 6, -3 to the dot product of 2 and 4. So in this case, we're going to end up with 6 times 2 plus -3 times 4, which in this case we're going to get 12 minus 12, which gives us 0. So here for this first one, the work being done on the particle as it glides from -3, 3 up to 5, 1 is actually going to be 0. Now, the second one says the world's strongest man pulls a log 200 feet, and the tension in the cable connecting the man and log is 3,000 pounds. It says, what is the work being done if the cable is being held 15 degrees from the horizontal? So we have to look at what exactly is going on here. And so one of the things that we know, again, is we know my force. My force is going to be the tension between the cable and the log, so the 3,000 pounds. And then it's going to be the component of the cosine of my angle and the sine of my angle. Since my angle is 15 degrees, it's being held 15 degrees off the horizontal. Okay, so what does it actually mean? Well, if we kind of looked at our picture here, we are holding this cable up. It is very, very small. This angle here is that 15 degrees. We would have your vertical and your horizontal. And the tension in this rope has got to be that 3,000 pounds that we are working on. And so here we would have your sine of 15, and on the bottom would be your cosine of 15. Okay. Now with this, we also have to find or look at what our distance is, okay, or the vector in motion. Well, this has to deal with what you're doing, and you're pulling the log 200 feet. So we're trying to pull this log 200 feet along this horizontal here. So this would say that we are moving 200 feet in the horizontal direction, but we're not going to go up any. Okay, so that is what we have. So the first thing that we have to look at is we have to look at my work, which again is the force times the dot product to your motion. So this is going to be my force, so it's going to be the 3,000 with the cosine of 15, sine of 15. And we're going to dot product that to the 200 and 0. So here, one of the things that I would do right off the bat is distribute that 3,000 in. So here you're going to have 3,000 cosine of 15, 3,000 sine of 15, to the dot product of 200, 0. Remember, your dot product says we are going to take the first times the first. So this is going to be 3,000 cosine of 15 times 200 plus 3,000 sine of 15 times 0. This back part's going to drop off. This front part is going to leave us with 579,555.5 feet per pounds of work. So there you go, 2 individual work problems, both of which are calculated using vectors, applying the dot product principles. So if you have any questions, please let me know. Otherwise, I really do hope that you enjoyed this super fast video. If you have any examples that you would like me to do, or anything that you are struggling with, please feel free to let me know. I'd be more than happy to work that out. Otherwise, I look forward to seeing you in the future.